Welcome to our deep dive into pointers in C. Pointers can seem tricky at first, but they are a powerful tool in C programming. Today we'll break them down step by step. Let's get started. First, what are pointers? A pointer is a variable that stores the memory address of another variable. Think of it like a label that points to where a value is stored in memory. Imagine your computer's memory as a grid of boxes. Each box has an address, and a pointer tells you which box contains your data. Let's see how to declare and initialize a pointer. Here's a simple example here. Num is an integer variable with the value 10. Int star ptr declares a pointer to an integer. The num operator gets the memory address of num and assigns it to ptr in memory. Num is stored at a specific address, say 0x100. ptr now holds the value 0x100 pointing to num to access the value stored at the address a pointer is pointing to. We use the dereference operator. Here's how in this example star ptr accesses the value at the address stored in ptr, which is 10, and assigns it to value. Think of dereferencing as opening the box at the address the pointer is pointing to and retrieving the value inside. Pointers can also perform arithmetic operations. When you increment a pointer, it moves to the next block of memory for its data type. Here's an example with an array. ptr initially points to arr0. After ptr++, it points to arr1. This is because incrementing a pointer moves it to the next integer size block. Pointer arithmetic is useful for traversing arrays and other data structures. Pointers and arrays are closely related. The name of an array acts like a pointer to its first element. Let's see this in action here. arr is an array of 3 integers. ptr is a pointer to the first element of ar. The loop uses pointer arithmetic to print each element of the array. As the loop iterates, star ptr plus I accesses each element of the array. First, what are pointers to pointers? Simply put, a pointer to a pointer is a variable that stores the address of another pointer. This adds an extra layer of indirection. Imagine your computer's memory as a grid of boxes. Each box has an address, and a pointer points to one of these boxes. A pointer to a pointer points to a box that contains the address of another box. Let's see how to declare and initialize a pointer to a pointer. Here's a simple example. Here num is an integer variable with the value 10. ptr is a pointer to num and pptr is a pointer to ptr. This means pptr holds the address of ptr. In memory, num is stored at a specific address, say 0x100, ptr holds the address 0x100, and pptr holds the address of ptr, say 0x200. To access the values using a pointer to a pointer, we use multiple dereferencing operators. Let's see how here star ptr gives us the value of num, and star pptr also gives us the value of num by dereferencing twice. Dereferencing pptr once gives us ptr, and dereferencing it again gives us num. We can also modify values using pointers to pointers. Let's see an example. In this example, star pptr 20 modifies the value of num to 20 by dereferencing pptr twice. Dereferencing pptr gives us ptr, and dereferencing ptr gives us num, allowing us to change its value. Pointers are essential for dynamic memory allocation. Functions like malloc, alloc, realloc, and free manage memory at runtime. Let's allocate memory for an array. Malloc alloc allocates memory for 3 integers. We check if the allocation was successful, initialize the array, print its values, and then free the memory. Dynamic memory allocation is crucial for handling data whose size isn't known at compile time. Pointers can also point to structures. This is useful for dynamic structures and linked data structures. Here's an example. In this example, ptr is a pointer to a person structure. We use the arrow operator to access the structures fields via the pointer. This allows us to efficiently handle and manipulate structures, especially in dynamic and complex data structures like linked lists. Pointers are a powerful feature in C that offer direct access to memory, enabling efficient and flexible programming. They can be a bit tricky to master, but once you understand their fundamentals, you unlock a new level of control over your programs. Make sure to practice, experiment, and gradually dive deeper into advanced topics like pointer arithmetic and function pointers. Stay curious and keep exploring. Happy coding!